Hello everybody and welcome to another exciting, hair-raising, fun-filled, adventurous episode of Radiorama, where I show you how to work on primarily radios and tube-powered electronics from the 1920s through about the 1960s. And today we have a Zenith Model 4. Dang it, I try to look at these model numbers and remember them for a few seconds, but I think it's a 4A40. And it is a little portable guy that's either AC or battery powered. I'm trying to get it open one-handed here. All right, here we go. And yeah, 4A40 is the model number. It is a 4-tube set and has a solid-state rectifier in the form of a selenium rectifier, which is more than likely underneath this little box here. We can see these little vent holes here. And this radio actually still works fine, but I don't trust leaving the original wax and electrolytic capacitors in a set once they get to be this age. And I've actually had this kind of sitting in the back for a little while because the challenge, and I haven't taken it out yet to see what I'm dealing with, there's no room underneath here. You see how skinny that chassis is? There's no room underneath. And so my challenge is going to be how to mount the new electrolytics. I've seen some people, what they'll do is they'll saw the electrolytic can apart and then they'll stuff the new caps inside. I've never done that before. I might have to do it in this case. I don't want to, but otherwise I'm going to have to find another place to stick them. I was hoping maybe there's just enough room underneath. I got the smallest sized capacitors I could find for this task. So we'll see. I'm going to take the chassis out. Looks like the speaker just disconnects with these little jumper cables here, and pull the knobs, and it looks like there are not much holding it in here. There's these two screws here. I think that's really about it. Not much to do to get this apart. Sometimes you have the screws that hold it in underneath the handle here, but I don't think that's the case. So let's pull it out and see what kind of trouble I'm going to get myself into. Okay, well this is the chassis pulled out, and I removed the bottom, and there is like no room in here whatsoever. And I mean, even if I do that, it barely clears that area. And the other thing that's a little troubling to me is you've got two power resistors here that are really close to this area. That probably generates a lot of heat. In fact, they knew it generated a lot of heat, because what we have here is a compressed sheet of asbestos. It's basically asbestos cardboard. And I'm actually going to leave it in here. What I'm going to do is probably spray it with something like a polyurethane or some sort of finish, just to kind of seal it up to keep it from coming apart. But it's in there for a reason. It's in here because this area right here probably gets pretty damned hot. And you can see we've got ceramic discs, capacitors, which are these red, orangish guys, or whatever, I'm not sure what color that is, brick red color, and these two power resistors. So that's going to generate quite a bit of heat. That's probably why they got these big slots in the side. Get a little more ventilation in there. But yeah, this is one of the most compacted chassis I've seen. It makes me think that I'm going to have to be creative with this installation. The other thing, no, I was thinking maybe the capacitor's okay, but you see, this is hard to film. You see this black gunk here? That's basically the capacitor's innards oozing out through the case, which means there's been some trauma in there, and it wouldn't be good to leave that in there. Yep, this is going to require some interesting engineering workarounds. All right, change of plans. I decided not to restuff the capacitor. It's just too big of a pain in the ass. There's 10,000 wires going to it. So I've started doing what I'm trying to describe as like a space creating technique. Originally, this big fat capacitor was here. This little guy, this is the safety grounding cap that goes to chassis. It was this big, and it was over here. I just moved stuff around, and I took the cardboard sleeve off of the can. I'll probably put it back on when I'm done. But the unmarked depression for the phenolic spacer, or for the cap itself, they're marked behind these lugs. And this one is the 200 microfarad 10 volt cap. It's only got 2 little leads going to it, so I'm relocating that electrolytic because it's so little out here. My biggest concern is the one that has these big power resistors hooked up to it, and that is the 100 microfarad cap. That's physically the largest cap. And the third one is this guy, which is also really tiny. So I think I can fit them in here, but again, I don't really want to have them over here. I want them kind of out of the way of the heat. And this is called being creative. I'm just basically relocating a lot of stuff to make it happen. All right, so here's our fix. So I was able to just relocate all 3 of the electrolytics away from the original mounting. I just ran jumper cables. And I put a little glue underneath this one, a little silicone. And I'm also probably going to add a little dab of silicone here. Silicone will hold up to hundreds of degrees. You can use it in your ovens, believe it or not. I mean, this stuff's not even moving around. Like, it's hard for me to actually get in here with my finger and move it. It's all really tight. I'm just doing this for a little added insurance. I might even put a little dab here. But I think this is going to work. I am going to test it now that I've actually replaced these electrolytics to see if it hopefully still works. If it doesn't, that'd be a damn shame, since it was not easy shoehorning all these parts in there. Okay, it works pretty well.
Commute for 280 travelers. I have a sense of...
Oh, that makes me happy. The hardest part of the job is now done. I say that, but I haven't seen what's going on with this selenium rectifier. It's probably just as crammed in there as the rest of everything in this set is. Okay, so here's the next stage of the restoration. First of all, I did get all the caps in this thing replaced. I mean, they just barely fit in there. So we're going to replace this selenium rectifier. It's probably fine. These portable radios didn't really get that much use because batteries were expensive, and if you were going to listen to the radio in the house, you probably had a nicer set. But I'm going to replace it anyway because this material does deteriorate with time. It just basically builds up more and more resistance, and eventually it can fail, and when they do, oh my god, it smells like rotten eggs exploding. So you don't want that smell in your house, and also it's kind of toxic, so better the reason to replace it. And luckily technology has changed a lot. We're going to replace that big blue thing with this little guy, but we have to compensate for the added efficiency that this new diode's going to have compared to this old one. And so if we were to just stick the diode in there, you'd have too much current, you know, flooding its way through the set, and that can make the lifespan of your tubes fall much more drastically. So I'm going to add this power resistor between the anode of the diode and the positive incoming line here, which is, you can see this marking here, it says positive. And what I'm going to do is just going to hang one end off of this existing rectifier and then take the positive out of circuit. And I know there's other ways you can do it. You can use a terminal strip, but I mean, you've already got a terminal strip here, so why not? So I'll stick that in there, and then again, we'll test the set to make sure we're still working. And then it's going to be on to cosmetics, and also the addition of the also famous audio input, even though I'm kind of wondering, can it happen? Is there any room? That's volume. Yep, there is. I figured it out. Alright, so let's replace this diode. And hopefully I won't get it backwards, because if you do, you'll fry shit really badly. Okay, so we got our little bitty diode and our power resistor installed. And I'll just keep everything really, really tight so there's nothing that can really wriggle around, even though I am going to put a little dab of silicone glue over that just for shits and giggles. But anyway, let's try it out again here.
Stressful in the past, it's going to get a whole lot tougher. Optima naturally has this advice.
Well, it seems to be working pretty good. Let me see what this is doing here. Oh, it's just a little warm. That's fine. You know, usually at 40-50 ohms is all you need. I think that's a 3-watt. I can't remember. It could be a 3 or a 5-watt fire resistant resistor. I used to use 100 ohm resistors in these. You really don't need to do that. Usually 50, maybe 75 at the max is fine. Okay, so now that the basic radio electronics is done, I'm going to work on the case. I kind of dig it because it's kind of got this copperish coloration going on in the grill. I'm not going to polish that because I get a feeling it's probably got some sort of coating to make it look like that. But I am going to use my favorite product that I mention every time I have one of these shows, which is Novus number 2. I find like number 2 works on most about anything. And I'm using an old sock to rub it in, and then I have an old sock down here to buff it out. And I usually do this at the end of the day because it requires no brain power. And it's kind of mind-numbingly boring, and I can sit here and have a beer and listen to my music and just polish away for an hour or two. Alright, well, the polishing's coming along pretty nicely. I think I'm going to take the emblem off. That was supposed to have originally been brass and shiny. And that just disconnects from inside there. It's usually just held in with, I think it's just twisted in there. I'll take it out and I'll polish that up, and then I think this guy will be done. Looks pretty good in my opinion. I wish it wasn't cream colored, maybe something more exciting, but whatever, it's fine. Of course, the FedEx plane is flying overhead as usual. I've actually gotten good where I can actually recognize commercial jet planes now. I can tell whether or not it's an old DC-10 or if it's a Boeing or whatever. Not a very useful skill, I guess, since I don't do any flying. Anyway, this is the last part of the project, and this is going to be difficult to film, so this may not be fun to watch. Anyway, usually I have access to the volume pot, which is where we're going to run our audio signal in, and it's buried in there. And so every one of these volume pots has 3 legs. There is a top of the pot, and then there's a bottom of the pot, which is usually the negative. Top of the pot is where your incoming IF signal comes in, which then gets amplified by the audio amp part of the chassis. So what we want to do is run an audio signal into the top of the pot. And usually it's easy to get at the 3 different legs, and you just mount it real close to the volume pot. But I can't do that. There's no room underneath. I don't want to put this on top of here because that's my vent for keeping this guy cool. This, by the way, is called an isolation transformer. It has a primary and a secondary. The primary on this is 120 volts in. The secondary output is 12 volts. So it's quite a huge reduction in the current potential going through this thing. And that's not all. The incoming audio will come through the secondary, and we need to split up the right and left channels. These are 200 ohm resistors. Then their ends are tied together, and that makes you have proper mono without potentially damaging your input device. This is the negative side, and over here we have the primary going to either side of the volume pot, which we're going to have to find another route. And this is the negative. And we have this resistor, which is half the value of the volume pot, and this little .02 cap, and this will preserve the set's AGC with that interference from this transformer when you turn the switch back on and off of the IF signal, which is the next thing I need to talk about. So I traced the wires coming from the pot, and the white and green, well, the white is my IF signal. And then the other side of the pot, which is the ground, is this gray wire here, and that goes to the floating ground of B+. So that's not too bad. This is almost impossible to film. Buried under here is the IF transformer, and I need to basically cut a splice out of the white wire that's going to it so I can turn that signal on and off. And I think because it's impossible to get at that, I'm going to do the splicing up here. It's going to be this white wire, and we'll just put it together, maybe put a little electrical tape around it. This is really low voltage. It's like millivolts probably. And then these wires are going to have to run into the chassis. I'm going to go through this hole, and likewise this one side will go to the top end of the pot and the other side goes to the negative. And then we'll have to run the switch, which is splicing this guy for the switch activity. All right, I hope that made sense. So let's go for broke. Let's wire this stuff in. Okay, the deed is done. We have our audio cable. I zip tied it to through two of these holes here. That comes over and attaches to right and left channel, two 100 ohm resistors. Then the negative side of the incoming line goes to the negative of the secondary, and then all this crap goes either underneath the chassis or into the volume pod area. I was able to pull this side cover off and get access to that. And then I've got this wire coming out of the back. This is the wire that will switch the IF signal on and off, and I made it excessively long, so I'm not sure I'm going to put the switch. But I've got a signal running through it now. So you see now the audio is clean, because again we have this wire that will enable us to reattach the IF signal to the circuit in case someone wants to listen to good old-fashioned AM radio. Anyway, I'm spending more time on this because my wife I have to go pick her up at the airport at midnight, and I'm not sure if I can stay up that late. Sorry, my Bluetooth just turned on again. Alright, so it's back together again. This one definitely took more time just because everything was so, like, such a small cramped area to work in. But I've had it on here for about 30 minutes and it works pretty well.
Just let it go. Don't that tickle you?
Kind of amazing. That's a little speaker, but it doesn't sound half bad. Anyhow, I'm going to let it run here for a while, make sure nothing's going to catch on fire after it's been rebuilt. You kind of want to make sure that if you've had something that's been out of service for who knows how long, 40, 50 years, that you let it get to its maximum operating temperature so that if anything's going to have a thermal breakdown, it'll be then. These things aren't as bad as, like, you know, for example, like an AA5 or something where there's a lot more heat being generated by the tubes. But still, there's some power resistors in there, so they should be allowed to operate to their maximum temperature. Anyhow, guys, thanks so much for watching. I was kind of putting this one off because I kind of sometimes hate working on portables, but this is pretty snazzy looking. And so until the next time something obsolete like this comes across my bench, I'll see you next time.